I was asked to talk about, for example, ethics. Actually, basically, the aim of this whole course, this prescribed by UGC, is that when we are doing research work and when we are writing papers or reports or conference proceedings, paper in a journal, normally all these what we write and submit for standard journals, these journals they have their own system of scanning our draft or manuscript for any similarity index. So I would ask or want to declare that please don't worry about the word plagiarism. The moment the word plagiarism is used, a chori bori no evo idea ave. Actually, plagiarism means similarity index, and somebody's results, how they can be similar. When we copy something from some source, by to word, page to page, या પેરાગ્રાફ ટુ પેરાગ્રાફ લેવો એ એથિકલ નથી અને એવું લેવાય જ નહીં. તો એની સિમિલારિટી કહેવાય. કોઈ સંજોગોમાં આપણા પેપરોમાં આવું કોઈ વસ્તુ ના થવું જોઈએ. થીસીસ હોય કે પેપર હોય કે એમફિલ હોય કે રિપોર્ટ હોય, જે કોઈ હોય, it should be original to us. We should not copy anything in toto from any other source. તો કરો તો એની similarity index will be very high. The moment similarity index is very high, then you are in trouble. And you know it, as far as the new UGC guidelines, if similarity index is only 10%, then only this thesis is allowed. Otherwise, if it is more than 10%, the thesis will be rejected as a draft. So it's very, very important nowadays. Now, when it comes to publication in research-based journal, I told you already, it's a standard journals. They will first scan our manuscript for similarity. If it exceeds 5% or more, and if they find that somebody's results we have taken, it is criminal. So we cannot copy any results from anybody. Results in the form of table, results in the form of figure, results in the form of discussion. And if at all you are taking those sources, they must be properly cited, but not from point to point or not paragraph to paragraph. So with this introduction, so what we have to do is, because I was told that most of you people are registered as Ph.D. students in South Gujarat University. Anyway, the South Gujarat University is my mother university. I did my MSc and PhD from the same university, from the Department of Chemistry, way back in 1980-85. So for the sake of the student purpose, let me just take you to this. Yeah. So what I thought was, well, let us think about scientific reporting and then ethical tips for scientific. That is why my talk is divided into different, let us say, a guide to, I don't know, this WebEx is not convenient to us. So there are so many things which are asking now. I don't know what these things are coming, that is a little bit trouble for us. Okay, then this talk will provide you, because some ball is coming, I don't know how to remove that ball. What are the different types of scientific literature? When we make a scientific report, when we write a thesis or MPhil thesis or a dissertation or a MSc project or a research paper, then we have to do a literature work basically. So that literature has to be properly cited. Then after that literature citation, we want to identify the gaps in the literature. What type of things are not explained properly? There is some dispute there. They are not clear. They are vague, and methods which are used may not be that good. So we may look at the problem again and then come up with some more results, new results, and with new methods. But we have to cite the literature background. So what type of different types of scientific literature we have, and what are the tips to write reports or scientific research, and what are the conventional rules about the format and content of an experimental report. Basically, we do an experimental in the laboratory, some data will come, or you have, for example, survey. That survey is basically data. So the data is coming. For some people, society itself is experimental lab. For science people, it is the lab which is an experimental lab. Now, what type of rules that exist? And then I would like to have get a clear, more dependable idea of how to approach through this writing situation.
కృష్ణార్లు కంప్లీట్.
Ah, scientists communicate the results of their research to other scientists. Basically, what we are doing in a scientific writing, because being a scientist ourselves, we want to communicate the results we communicate the results of their research to other scientists, to other peers, what we call, primarily through scientific literature, which therefore constitutes a permanent repository of scientific knowledge and a record of progress in scientific inquiry. Why should we report our results? Because it is for the sake of improving the knowledge, for adding to the knowledge. A thesis work is done basically to generate data, process the data, process it to the moment you have proper processing, you get a knowledge. Processed data is knowledge. I think this point one. So the moment you process your data, that processed data or information becomes a knowledge. Because this data is coming from scientific investigations, this is called scientific knowledge. And this scientific knowledge, it is deposited in the form of journals, in the form of full view. So we want to add to the repository of scientific knowledge. This scientific knowledge is stored in what? In these journals, books. Crystallized knowledge will appear in the form of a book. Book is a textbook. So naturally, book is a guidance to further research. That is why I am using the word crystallized knowledge is in the book. If it is a raw knowledge, it cannot be in the book. So all books, journals, handbooks, they are the repository of scientific knowledge. We want to contribute to it. So there are different types of scientific literature exist, which are referred to as primary, secondary, tertiary, and fourth one is grey literature. This is very, very important for any beginner, for research students. What do you mean? Because accordingly we have to treat this literature. What do you mean by primary literature? Primary literature refers to the accounts of research carried out personally by an individual scientist or as a collaboration by a group of scientists, which is published in a peer-reviewed scientific journal. I'm not getting into these words, peer-reviewed scientific journal. It is a standard journal I'm using the word. Otherwise, UGC has got what is called care list. UGC care list. For any job in future, even for PhD, you must have publication in a journal which is listed in the UGC care. If it is not listed, these journals are called predatory journals. They are publishing papers by payment basis. They have no value. They have no quality. So if you take a journal, please look into peer-reviewed scientific journal which is listed in the UGC care as far as our concern. In that journal, if the accounts of research are published either by an individual scientist or a group of scientists, in that group of scientists, research scholars become a group. So if you publish your research in that, that becomes primary literature. These accounts are commonly known as papers and they are written in a particular format. For any paper to write, there is a particular format that we will deal with in next slides. And this format depends upon the this format is called style. The style depends upon the journal. Okay. Normally, journals require a paper to consist of first you must have a title of the paper. You have to mention the abstract. Before that, you will have to have name of the authors and affiliation, contact details, then abstract, then keywords, then introduction, then material methods, results, discussion, acknowledgement, and references. Normally, this is the standard way of presenting your research account. Or when you submit a manuscript to a research journal for publication, you are supposed to have these things: title, abstract, keywords, introduction. I think this is known to you. Material methods, results, discussion, acknowledgement, and references, lastly references. Now, normally what we do, what is the process? Those senior research students also already know it. Once you have a manuscript ready with you, you submit to the journal. The editor, it is assigned to an editor. Editor will send this to a number of recognized experts in that area who call them as referees. Even the same thing happens with the thesis. Once the thesis is submitted, it will go to an evaluation by at least two examiners, one from Gujarat, one from outside, or sometimes it goes for the abroad also. Though, and what those referees or experts they will do, they will go through your paper, they will go through your results, they will go your discussion, and they give their opinion. That opinion depends whether the work is reported presents new scientific information and to report on the merits and deficiency of the work. This is what the reviewer report will be. The reviewer report would also tell you what are the merits of the work, what are the deficiency of the work, and they will suggest some more things. Sometimes they will suggest everything is okay, minor corrections, sometimes major corrections. In that major corrections, it may be a particular experimental result, particular way of representing the results. Sometimes we miss the cross references. They will ask you to look into some others' work. They will give you the references also. Then others' work also you have to look into if it is missing. Then you have to refine and revise your manuscript. So, depending upon this process, ultimately final decision will be taken by the uh, editor. Then the editor may accept the paper as it was submitted, may ask for a minor revision, or may require a major revision. The paper may be refused outright. Now, this process is called peer review. Any publications without peer review, it won't go further. I am just giving an example. You must be reading in this pandemic situation 2 days ago, the Indian Council of Medical Research, everybody knows about this now. They were telling that if you mix the vaccine, Covaxin and Covishield, together and give it as a vaccine, it is more effective for the third wave or Delta virus than the uh, than single vaccine alone. But they told these are their results, but they have not submitted to peer review, and that is why we don't want to disclose the composition. But they say that they have done some experiments, and that experimental result shows that a mixture of two vaccines is more effective than individual vaccine. This is the statement I am making. And this statement will be accepted by outside world when only your work submitted to a standard journal undergoes this peer review. If there is no peer review, your data will not be acceptable to at all. Now, when it comes to journal, choosing a journal, how to choose a journal? There are many journals, different types of journals, what we call international, national, regional, to local. And these journals are graded by some very many agencies. But what is important is the journals are now judged, are evaluated, are rated in the form of what we call impact factor. Impact factor is nothing but on the average how many papers published in the journal are cited by other other journals or other work. The number of citations that particular journal receives uh, in other journals, that number is very important. That number is called impact factor. In Thomson Reuters, nowadays it is called query weight analysis. They publish impact factor on a yearly basis. There are many teachings also. These journals, period journals, which are on paid basis, they also have their own way of calculating impact factor. They are called uh, journal impact factor, but that has no meaning. In UGC or any promotion, what is seen is Thomson Reuters. Now, this Thomson Reuters is an international agency. Now, it is called Clary Awake Analysis. They publish this list of impact factors, and that is why, sir, when he told me about biodata, he was telling about the publications in journals of this much impact factor. Each journal has its own SJIF, but it is not reliable. This is not reliable. Reliable is Thomson, right? Thomson and Reuters. Now let us say what do we mean by primary literature. What is primary literature? The literature which is the accounts of research published in secondary scholarly journals, and sometimes many times some research is published in the form of monographs, and of course, many times the literature is presented in the form of thesis, dissertation, conference papers, and reports. All this consists of primary literature, not only journal. It could be a monograph, it could be a thesis, it could be a dissertation. Unpublished theses are there, conference papers and conference reports. In the world of science, The contribution of individual scientists to the advancement of knowledge is usually gauged partly on the number of publications. Normally, what they say, how many papers you have published? 96 papers, 97 papers, somebody says 200 papers. Normally, this is very important previously, but nowadays it is not. Number is not important. What, in which journals you are published, what is the cumulative impact factor of your publications? Suppose if your publications are 50, then each journal must be having some impact factor. You add all this value, then you get a cumulative figure of impact factor, and that impact factor people see into that. Based on that impact factors total number, you have the what you call the credibility or the expertism of that impact. You know the word impact, how much impact your work is. Now when it comes to impact factor, there is one more thing, what is called H index. Sir was mentioning about H index. H index is nothing but number of times. Suppose you have published 50 papers. Out of these 50 papers, 30 papers you published are cited 30 times each. Each paper gets a citation 30 times. 30 papers you have, your impact, your H index is 30. If 5 papers are, whatever you have published, 5 papers are cited by others 5 times, H index will become 5. So this H index has become another very, very important factor in judging the work and the impact of your work. So this is our primary literature. The secondary literature consists of publications which rely on primary source. For example, it is not a requirement for the authors to have done the work themselves, since the purpose of this publication is to summarize and synthesize knowledge in a specific area for other scientists who already have an understanding of the topic. So that means what he is telling here, if you write a review book, if you write a review, or if you publish a handbook citing the other's work, it becomes a secondary literature. Then secondary literature includes review journals, monographic books and textbooks. For example, when you are writing a monographic book, what you do? You try to take a particular theme and take out the work which is already published by others in that particular theme, and then you review it. You order it in such a way that rather than reading 100 papers at one time, if you read a review, you will get a proper review. You will get an idea of what is already done in this work, what people are telling about it, what are the problems which are not answered, and what is the scope for myself. That type of information comes from review journals, comes from monographic books and textbooks, and handbooks and manuals. So I already mentioned it. So these are secondary literature. Secondary literature includes review journals, monographic books, textbooks, handbooks, and manuals. Okay. On the scientific style, secondary publications normally, the secondary reviews, they are not organized in the same way as primary publications. This is very, very important. Scientists use the secondary literature to gain an overview of research area. That's what I'm saying. For a beginning person, if you want to enter into that area and do some work, what you have to do is you catch hold of some of the very good reviews which are available in the topic, and then you can read them and you can get an overview of research areas which are close or relevant to their own, and you can get familiarized themselves what existing research, what are the new topics which you can plan to start working. So this is what is called problem searching. If you are looking for a research problem, you must go for the reviews, handbooks, along with the primary literature. Now, tertiary literature. What do you mean by tertiary literature? It is nothing but that are the literature is based on primary and secondary sources that are aimed at scientists who work in different areas from the subject matter of publication or towards publication. Examples of tertiary literature includes science magazine, stories. They are some reports, some stories, newsletters, science articles in newspaper. If you publish a science article in a newspaper, which you read in newspapers, it becomes a tertiary literature. It is not primary, because they will not be having a format. They will not be having a table, figure, and results much. On the contrary, what will happen? They will have a summary of popular articles based on what is already researched. And this is called uh, tertiary literature. Encyclopedias come under that category. Introductory textbooks come under that category. Science articles in newspapers come under that category. Science magazines and newsletters. Now, this is very important before we proceed. Grey literature. This grey literature is refers to sources of scientific information that are not published and distributed in the usual manner. Now, grey literature includes theses. If you have a thesis, you get a PhD degree out of it. You have MPhil dissertation or MSc dissertation. After dissertation, it is put in the university library. It won't go anywhere. Nobody knows what it is. If you have written a technical report, it is not distributed. It is put in a library. If somebody goes to the library and they may refer it. Otherwise, it is not a public domain. So the moment it is not in public domain, then you call it as a grey literature. Grey literature has limited exposure to others. So that is why this problem. Now, this happens with the environmental impact statements, government documents, for example. Government also made a lot of surveys, and that survey reports are not made public. They are there for the decision making. They are there for some information to the government itself. For example, working paper. Some people write a working paper, but that's not publicly available. It is only available to the agencies for some agencies for making decisions. And online documents, sometimes online documents are made, but they are all classified as grey literature. Of course, grey literature does not mean it is having less scientific merit. No, it has equal merit as any other literature. Gray refers more to the limited distribution and difficulty of assessing the publication than to its content. Content is not questioned when you say gray literature. It will be, it will be, what is important is what is the extent of distribution of this material. If the distribution is wide, many people can access it, many people can read it from different distant places. It will not be called as grey literature, but grey literature means limited distribution and people have difficulty in assessing this publication. So that is about grey literature. Now, I think I should go fast a little bit here. Books, of course, books also are there. Conference proceedings. These conference proceedings means, papers presented at international, regional, national conferences, workshops, symposia, they are considered primary literature if they are peer reviewed and published. This is very important. Unless and until they are peer reviewed and published, you cannot have primary literature in the conference proceedings as a special issue of science. Sometimes these conference proceedings are put to a scientific journal, and the scientific journal publishes a special issue. You may be knowing this, and that special issue also it will undergo peer review. Without peer review, without publication, you cannot call it as primary, even though the data is very very important. For example, many conferences, what they do, they ask us abstracts. We send the abstracts. The abstract book is published. Published means it is put in a bound form and which have not been peer reviewed. So that is why they are not counted as primary literature. So anyway, that is what is very important. But sometimes people ask for extended abstracts where the results are there, and if these results are subjected to a peer review process and the booklet is published, it becomes a primary literature. Now, when it comes to internet, nowadays, whether it's a boom or a mess, we don't know. Because in internet, when you assess the information, you get all sorts of information, except journals. Journals, okay. But with otherwise, it becomes absolute rubbish to high quality. Many times, good information is available on internet. Many times, it is rubbish also. So don't go by what you see in the internet freely available. Best one would be you must always look for, when you are a new researcher, look for primary peer-reviewed scientific journals that are published online or offline. So that is very, very important. And based on what is written in a blog or what is written on internet, you don't think you don't get an idea about really what is the knowledge available there. So websites also not a so users of the internet should be very carefully evaluate the source, quality, and accuracy of information they plan to use. Okay, now let us quickly summarize this one. For example, if you have an experiment done, then you have to write it up for a review. So, so now what are the precautions we have to, take when you think of when you are in a position to do an experiment, get some results, and you want to communicate with the journal. In that case, please try to think beyond the lab. You must know what others have already done. મારી લેબમાં હું ફાઇનલ છું બધું એવું ના ચાલે. In fact, you are a part of scientific community and the people who participate in this community tend to share the same values. So you must know what others have done. As long as you understand and respect these values, your writing will likely meet expectations of an audience, including your reviewer. If you have not cited others' work in the area, the reviewer will simply return your paper and ask for more things. Why we write these research reports, for example? Because the guide as a no. Normally what we think, a guide ને કીધું છે, guide કીધું આ કરી, એવું નથી. For example, people investigating some scientific hypothesis have a responsibility to the rest. When we are writing research report, we have a responsibility, a scientific responsibility to the rest of the world to report their findings, analyze this data. They analyze it in the form of existing what is known, what I have done, what new information has come, what more contribution I have done. Those things are, this is a communication like that. So otherwise, if you have simply follow what guide says, that is not a proper literature or proper, that is not the proper way of working as a research student, and that is not the proper way of being a researcher. For a researcher, you must have uh, you must have your own ideas, you must have your own information gathered, you must also find your own, you must also have findings of others which are legitimate. So your job as a writer is to fulfill these two goals, right? So because guide said no. Now, for example, this is already told you, any research report: introduction, materials and methods, results, discussion. Then you have this is normal format: introduction, methods, materials, results, and discussion. This format is called IMRAD. I for introduction, M for methods and materials, R for results, and discussion. It may take slightly different shapes depending upon the audience. So depending upon which journal, which magazine, which newsletter you are following it, you will have little bit different format. But otherwise, these four are the basic components of any research report. Now, some ask you to include an abstract or separate section for the hypothesis, or call the discussion section as conclusion. Some other word will come conclusion, or change the order of the section, not this order. However, the IMRAD format was developed, things which are not sent for reviewing process, they are not considered a primary literature. But if the conference proceedings are properly, edited, properly reviewed and published, they can be considered as a primary literature. So now next one, sir, 15 number, the extended abstracts. Many conferences, they will ask you for the extended abstract, where the abstract is only one page abstract, but extended abstract has got all the features of a publication paper. Then it will have abstract, it will have introduction, it will have materials and method, it will also have results and discussion along with a few references. If that is the case, and if that particular extended abstract paper is reviewed by the peer reviewed, then it can be considered as the primary literature, unless and until any research report which is having a particular format and does not undergo peer review, it cannot be called as a primary literature. Normally, a research paper must be a primary literature. That is very important. So don't go by one page abstract, 2 page abstracts. That's what I wanted to convey. Sir, next one, sir. Next one is 16 number. In this 16 number, I have already told you that in the days of internet, a lot of information is available. Like social media, when you are in social media, you get lot of news and lot of information. Sometimes right, sometimes wrong, sometimes fictitious, sometimes misguiding. So you have to be very careful when you are referring to some literature, some information. which is available on in the internet. But remember, if the information is coming from primary literature, don't worry. But if it is not coming from primary, secondary, tertiary, or grade, if it is coming without any source, we don't know the source, but information is available, don't believe it. You have to be very careful in evaluating this type of source for its quality and accuracy. For example, the information may be misleading. It may not be accurate. So you don't rely on that. You don't depend on such type of information. So that is why what I want to emphasize here is whenever you publish in primary, secondary, tertiary literature, then only it will be accepted. Any in any other source than these three, the content is viewed from contempt, and quality and accuracy reported are not confirmed and not guaranteed. So next slide is, sir, 70th slide. So when you do an experiment, when you want to report, think beyond the lab. Why? Because you have a particular responsibility to the scientific community. You have to share your views, your results to others, and similarly, while reporting your work, you must also share some other work, proper citations. If you don't have a proper citations, even reviewer will return the paper, saying that the paper is not written properly, previous work is not cited properly, and the comparison of your results with the other results is not done. Very, very important is when we do a work in a particular area, already some information is already available. That information must be compared, discussed, and if you are differing with them, then you have to explain why you are differing. If you are agreeing with them, you should explain how your things are different, how your quality is different. Then only the reviewer process becomes easy and the review will be successful for a paper. So many people ask you, next slide, sir, 18 number. Why do we write research reports? Why we write research report? Why should I write? I have done my work. It's okay. It's not like that. Why? Because if you are writing a research report, is because of the two important goals you have when you are writing this one. Because if you write a research report, people will read. When people are reading these reports, there are two primary goals. For example, they want to gather the information presented by you. They want to know that the findings are legitimate. So you must always report a work in such a way that it has the information which is new, it has the information which supports or differs from the existing knowledge, and if it is differing, you have an explanation to it why it differs, and at the same time what you have done or your findings are legitimate. So this is a very important job of a writer. That's very important. So I was referring last time 19 number slide, sir. Then the research report is basically organized in this way: introduction, methods and materials. Introduction means introduction to your topic theme, and there you have to cite what is already existing, and then with methods and materials you have used to do this work. Then you come to your results and discussion. This is the standard format. This format is called IMRAD. Though some journals have a little bit different sequence, but the standard format is IMRAD. Introduction, materials, results, and discussion. This is what I was trying to share with you. Now, sir, 20 number slide, sir. In introduction, what we do, many people have doubts, what is to be written in introduction, what is to be written in conclusions, what is written in results and discussion. Normally, the introduction means you must state your hypothesis. What is the hypothesis? Which hypothesis? And based on what reasons you have taken up this work? And in fact, it explains how you derived that hypothesis, why you come to that hypothesis, a conclusion, and how it connects to previous research work. This is very, very important. That is why you have to refer the literature, primary, secondary, tertiary, and grade, to find out what has already been done and known. Then you have to connect this to your hypothesis. Now you must also state the purpose of the experiment and study. Purpose, objectives must be clearly mentioned. That is what introduction is. Should not be too lengthy and too long, otherwise referees will tell you, reviewers will tell you. Methods. Methods means details how you tested your hypothesis. What are the methods you have used to test your hypothesis? You must also clarify why you perform your study in that particular way. Why are you using this method? Why it suits you such study. That also you have to explain in the methods. In the results, of course, you have got raw data, which is uninterpreted data collected, and you express the data in the form of table or easy to figure as percentage or ratios. These results are basically the data which you have collected. The data is presented in the form of tables or in the form of a figure. Now discussion, what we do in discussion, it considers whether the data you obtain support the hypothesis. This data, your hypothesis, introductory hypothesis and the objectives, how they are, they support the results you get, the data you get, the interpretation you make, how it supports your hypothesis. That you have to defend in discussion part. It also discusses the implications of your findings, how your findings are different from others, and how better you are, and judges the potential limitations of your experimental design. Sometimes we want to know more, but with my experiment is not allowing me to know more, then we have to state that yes, the experimental design I have, the measurements with which the instrument I use, that instrument may have limitations. And that the limitations are there, you have to mention those limitations. Sir, next slide. I think I should avoid all these things because this is very, very it make any difference if this piece were a different size or made from a different material? So this is also very important. If not, you probably don't need to get too specific. If so, what he says, would it make any difference if this piece were a different? For example, when you are taking a specimen and measuring some property, okay, you have got a specimen of this size, and so your property is this. Suppose if I vary my size, what will happen to property? Will it change or not? Suppose if this is the material of a polymeric material, if I use a nanomaterial, what will happen? Same composite nanomaterial, same composite polymer composite, then what will happen? Then you have to think about those things. Then if your answer is no, then don't get too specific. If answer is very close to each other, then you have to do so many things here. If someone so you have to think about that other sample also. Make the measurement. They will say that your data is insufficient for conclusions. Why don't you try more samples? So this type of queries will come from the reviewer. So from most crucial detail is measurement. You should always quantify anything you can, such as time elapsed, temperature, mass, volume. This is very, very important. For science people, this knows. Another one is rational. Rational means what you are relating your actions during the experiment. You explain your rationale for the protocol you develop. This is very, very important. So every section is connecting your hypothesis, your objectives, why you choose this material, what properties you are measuring, why are you measuring, what measurements already gave you, whether those results are discussed in tune with your hypothesis. Then that rationale you have to uh, you have to state and be clear about it. Now, critical thinking is very crucial in all this process. Research is a very, very intense subject. Research is a very expensive subject. Research is a very time consuming subject because we cannot come to any conclusion based on a cursory, based on a one or two single experiments. You have to do a critical thinking about your data, and it is very, very crucial. For example, if the same things are run by robots, nowadays you know it, you can have an intellectual robot, it can also do experiments, but it doesn't have brain. Any robot, any computer cannot do research. Computer has to be run by the brain. is a tool, robot is a tool, the instrument is a tool, but who has the brain? The researcher has the brain. He has to apply his brain, he has to apply his mind to find out what is happening, why it is happening, what is the conclusion. This control, whenever you are doing experiments, you must have a control. Control means which is standard or which is already well accepted. The control is exactly the same as other items you are testing. You don't manipulate. Okay. So the control are what is called standard. When you are doing a thermal measurements, when you are doing a DSC experiment, you are always mentioning control. For example, when you are doing a simple titration, our water is a control. If there is no change in water, but if you have a solution, some conductivity changes, pH changes. So that is why what we call blank. That blank or control is very, very important. With reference to that control, then only you can have it. So I am just avoiding these highly descriptive things. Results, of course, I'm not. How should be the table? These are basically written for an extensive course of 6 days about really how to write a paper. That we do in our year. What we do is we take about 6 days, 7 days for one type of this type of lecture, and then at the end of the day, at the sixth day, we give a project to them saying that they have some results are given to them, some literature is given to them, they have to write it as manuscript, and that manuscript has to be submitted as a project. So we assess it and give marks. Okay, in science, the credit goes to the man who convinces the world, not to the man to whom the idea first occurs. This is very, very important. Whenever in any science, the credit goes to the man who convinces the world. You must convince your results and you must convince your world, not to the man whom the idea first occurs. You have the idea. You are the virgin. You are the original person who have that idea, but you did not convince this to the people. Then credit never goes to you. This is very, very important. So that's what Darwin. A matter of difference, for example, subject matter, writing, constraints, audience, purpose, occasion. Okay, this is not that important. Now we let us spend a little more time on this ethical tips for authorship. In the end, if anybody has some questions on scientific writing or reporting scientific papers, any questions are there, I will definitely try to answer you. What consists of results, what do not consist of the results, what should be in methods section, what should be discussion section, that can be discussed. Now, very, very important, one of the very important point is this ethical tips for authorship. Basically, my lecture is based on some American Chemical Society guidelines. American Chemical Society is a very standard society for science publications, physics, chemistry, and material science. Then we have Royal Society of Chemistry. These standard publications, they have their own ethics. My slides are a little bit based on that. So ethics for typical authorship. Now, very important. Sir, if you are, I think my slides are there. Slides are there, na, sir. One is what is important is when you think about ethical authorship, whatever the authorship we have, whatever the claim we have, it should be ethical. For that ethics, what are the things we have to learn? For example, when you start your research work, you are navigating the seas of scientific publication. When you are an young author, when you are beginning your research work, you have to follow certain ethics before we do our work and publish it, report it and publish it. So, what are the tips and what is the difficulty? Number one, navigating the sea of scientific publication is not always easy. We have a sea, knowledge is exploded. We have a sea of scientific publication, so much data available. So, how to go about it is not always easy. So, that is what we do. Number two, follow some of the tips which will be explained in next slides to make your research, to make sure your research is published responsibly. This is very, very important. Publication is a responsible job. Third number, observance of high ethical standards is vital to the scientific community, and this can help maximize the benefits of your research to society and your fellow researchers. Very, very important. You are talking to your society, which is consisting of fellow scientists, and you are responsible for that. And you have to be ethical also for that. So you are talking about your scientific community, you are talking to your scientific community, your fellow researchers. They are going to look at your results very seriously. So you must maintain highest ethical standard. So I told you already, this my ethical standards are common standards which are taken from American Chemical Society publications. They are very standard publications, and they give this ethics part. Sir, can we go to the next one, sir? 54.
Yes.
So 54 says that, first point, be accurate and truthful. These words are very, very important. Be accurate and truthful. Accurate means what you have measured, you are reporting. There is no deviation what you measured and what you reported and what you are compared with others. That is accurate. What may accuracy means? Whatever I got, I am reporting without any manipulation. And that reported thing is compared with the others who have already done. If you do all these things, you are accurate. And you have to be truthful. For example, an author's central objective is to avoid deception, no cheating, not to lie, not to give a wrong data, measure something and reported something. No. You must present an accurate and complete account of the research performed. Whatever you have performed, whatever the limitations your experimental methods have, you must be accurate. You must do the same thing. You should not change or manipulate. આપણે MSc થી BSc થી સ્ટુડન્ટ્સનું આપણે એક ભણાવીએ છીએ અને એ ખોટું કરાવીએ છીએ. દાખલા તરીકે લેબોરેટરીની અંદર રિઝલ્ટ હોય, they bring pencil and rubber. પહેલા રિઝલ્ટ મેજરમેન્ટ લઈને પેન્સિલથી રખે, પછી ફાઇનલ થયા પછી પેન્સિલ. હવે કેમ પહેલાથી એક્યુરેટ હોય અને જે બરાબર પ્રોપર કર્યું હોય, વોટ એવર યુ ગોટ યુ રાઇટ ડાઉન. I don't allow my students any pencil. Any strict teacher will not allow. On the contrary, we should encourage them. Make the solution proper, make the instrument okay, standardize the instrument, operate properly. When everything is okay, simply measure what you get. There is no pencil, there is no pen, there is no rubber. So that is why this is called presenting accurate and complete account of the research performed. Okay. Second thing is, make sure, each word is very important here. Make sure your research report and collected data is as detailed as possible. It should be detailed to aid in reproducibility. This is very, very important point. For example, many people ask you or ask me, what is a scientific experiment? Scientific experiment is the experiment if it is repeated elsewhere, same data you should get. Same system, same conditions, same instrument. If the measurements are done in America, measurements are in Germany, India, or Germany and Japan, the result should be same. That is reproducibility. Reproducibility is one of the very important facets of research, scientific research. If it is not reproducible, it is not scientific. It is unscientific. We science people cannot be unscientific. It is wrong. It is subjective. So scientific data is objectivity. Objectivity means it cannot change. It cannot change depending upon who is the experimenter, which country you are measuring, which instrument you are measuring. No. Scientific results are always reproducible. Same conditions if you give, it should give the same result. That is reproducibility. Second thing is, if you repeat the experiment again and again, you must have same data again and again. And based on this repeated experiments, we can calculate what is called precision. I know that in your research students, there must be some statistics and mathematics and chemistry people. You must know what is precision and what is accuracy. So you must have the collected data should be precise and should be accurate and should be detailed so that the same experiments, same conditions, if repeated, you will get the same data, same report, the same result. Okay. Number two, give credit to those who did the work. I'm talking about ethics as a point of view of author. Ethical tips for ethical authorship. That is basically what I'm trying to tell. Sir, these two number you have seen now. Give credit to those who did the work. Many times it won't happen. But a scientific worker must give credit to those who did the work. That means whoever has helped you in measuring these things, in measuring your data, in writing the paper, in discussing the results, all must be having credit. That is why you must mention them as co-authors. The co-authors of a paper should be all those persons who have made significant scientific contribution to the work reported. Not only that, these co-authors share the responsibility and accountability for the results. So co-authors is very, very important. If you mention a co-author, he or she must have contributed significantly to the work, to the discussion, to the reporting, to the writing, and that co-author must share the responsibility and accountability of the results. We cannot say that I have not done this, some other person has done. Then you have no business to be a co-author. So, friends, when we do a group work where more than one person, two persons are involved, be careful to choose the co-authors. Choose those co-authors only who have made significant contribution to the work which you are reporting. And these co-authors have equal responsibility and accountability for the data. So this is about giving credit to those who did the work. If you don't give the credit, or if you give undue credit, it is not ethical. Ethics means whoever has done, he will get the share. Whoever has not done, he will not get the share. So this is what is important in the ethics point of view. Give credit to those who did the work. No other reason for to be a co-author. Sir, next slide, sir. 54. No, 56. This 56 is very important. If you have changed it, cite all sources. I'm talking about tips to ethical authorship. You must cite all sources. When you have done an experiment, when you are started writing it, interpreting it, you must have referred to many, many sources. These sources can be primary, secondary, tertiary, or gray. I have already explained you what these four literature sources mean. You cite all of them. So that is why if you do not cite and if you claim that it is yourself who has first proposed it, it's not ethical. The reviewer will know. That is why this review process is there. Reviewer is a senior person with much more experience who can independently look at what you have done. If he finds that you have not mentioned some findings by others, he will advise you to refer, to read, and and cite that work. So that is what is important here is from ethical point of view, give credit when credit is due. Be sure to cite anything that influenced your work, and that is not a common knowledge. So if you have read something that inspired you, that influenced you in understanding your results in your discussion, please cite that work, because that reading, that literature which you read deserves a credit. So you should mention that. For an ethical person, you must mention all the sources and cite them in your work. This is another third ethical tip. Not many, but very, very important. Now, fourth one is very important. Ethics, na? Ethics means moral, which is correct. If you don't do it, you are unethical, immoral. Immoral things in science land you in a lot of problems. Your reliability, your credibility. Nobody will believe you when you say something. If you are ethical, everybody will believe. The fourth important tip is report all safety concerns. This is very true in case of chemistry, in case of electronics, because certain things when you are doing, there may be some explosive reactions, there may be some problems which normally come, but you have to report all these safety concerns. For example, when you are handling equipment, procedure, or chemicals, identify any unusual hazard inherent in the chemicals. Some chemicals are hazardous at particular temperature. There may be a lot of vapor, there's a possibility of explosion, catching fire, or some chemical vapor is harmful, injurious to the health. Then you must report what you have observed, what you have felt, and safety, so that other people will avoid it. So you should, that's what I'm telling. You are responsible for the scientific community. Others, they will follow what you say. If you find that a particular process or chemical is hazardous at some point of time, in some kind of experimental conditions, you must mention, so that people can avoid this procedure, this chemical, or take precaution when they are doing this work. This is very, very important. You might have seen that many factories, many times in India, if you have a big factory, they have a lot of storage silos where these hazardous chemicals and gases are stored. Once in a while, there's a leakage of, even leakage of chlorine gas. It kills many people. So that is why the factory failed to report that around this reservoir there is a danger of this chemical, so avoid coming close to it. There should not be houses nearby, and that is what safety concern is. But in many places we see, if there is an explosion in a factory, there is a leakage in a factory, many people die because safety concerns were not done. Safety concerns were not reported. The ethical thing is always report safety concern of material which you are using, chemical you are using, equipment you are using, or any procedure you are doing during your investigation. To do this, you are behaving ethically. Sir, next one, 5 number 1. Now, this is very important. Many research students tend to do this. Avoid fragmentation. When you have done work, when you completed some work, you wish to publish 2 papers out of that, just by fragmenting your data, dividing your data into 2 parts, one for this paper, another for that paper. But these two works may be related. So what you have to do, you avoid unnecessary fragmentation. In fact, you should provide a well-rounded account of your study, one paper, not several papers. નંબરમાં મત પડો. કેટલા નંબર પેપર થયા મત પડો. Number has no meaning. How impactful these results are very important. Many great scientists have written only 20 papers, but their names are there for hundreds of years. It is not the number which is important, it is the quality which is important. It is the actual results at one place is important so that it gives a comprehensive understanding. Okay, sir. Then can you please go to the sixth number? This is very important and ethical thing again. This says that don't double dip submissions. Suppose if you have a manuscript written, you want to submit this manuscript to a journal. So at the same time, don't submit this to two journals at a time. This is unethical. Don't submit your manuscript to two different journals at the same time. That is unethical. What is ethical? You submit only to one journal, wait for the review comments, address them, get your work published. If that particular journal is not accepting your manuscript, then you can submit to another journal, but not simultaneously. So don't simultaneously submit your manuscript to two different journals. This is another tip. That is called don't double dip submissions. Don't double dip submissions. Now next one, sir, 60 number. I don't have much, I have only 63. Seventh tip. Each tip is a gold. It's a very distilled words which are used here, and they have deep meaning. Now seventh tip is, I'm talking about ethics for a good author. Keep constructive criticism. So constructive criticism means, for example, when you have an experimental study or theoretical study, you justify criticism, but that criticism should be professional and don't let it get personal. Constructive criticism should be professional, based on the data, based on what is observed. You are criticizing somebody's work. You are not criticizing because that somebody is your enemy or is your competitor and that is why you want to insult him. That is not good. Don't criticize for insulting others, for telling that others are inferior. No. You must do a professional criticism. Professional criticism means you must justify your criticism. Nothing is personal. The criticism is based on objectivity. Criticism is based on the data, the experimental things, and the conclusions drawn. Maybe sometimes wrong. Many times it happens that when you are writing new papers, you discuss about other results and tell that these results are not what we get, because those results were published or analyzed by a method which was old. Now modern instrumentations have come, more accurate results are able to we are able to produce more accurate results, so we can give an accurate analysis. And just because of that, you don't insult the old work, but you can still criticize it from professional point of view. Now 8 number, sir, next number 61 slide. Here, disclose potential conflicts. For any person who is publishing a paper in a standard journal, they will ask you publication agreement once it is accepted. In the publication agreement, we have to discuss or disclose any potential conflict. That means, what does that mean? The corresponding author should let the journal know about any relevant competing financial or other interests related to the submitted work. Suppose if some industry sponsored this work, when they paid you money, then the results are done for them, so it becomes their property. But you don't want to disclose that. You want to claim these results are done by yourself, by not for others. Many times we do work for others. Same is with the governments also. When you have a government funded projects, some of the projects case you need permission from the agency to publish these results, because these results were paid for it and you got the results, you submit to them. Unless and until they gave you permission, you cannot publish. So otherwise there may be a conflict. When the data is published, that fellow may know it, and he may write to the publisher saying that, look, these are our data, these publications are not to be done, so withdraw. So this type of conflicts will come. So you must disclose that this is funded by them and they have agreed to publish this work. So this is very, very important. When you are doing a consultancy work, when you are doing a sponsored research project, you have to be very careful what you can publish out of it, what you cannot publish out of it. Many times, if you take a certificate from them saying that they have no conflict, there is no issue. So next slide, 9 number, properly attribute published content. You must attribute the published content properly. For example, all text and images that are used from other publications, even your own articles, must be properly attributed. When I am quoting a result or a figure from other papers of my own or from others, you must cite it. This data is from this publication. That publication may be from your lab or from other lab. If you don't do this, you are in serious trouble of plagiarism. Plagiarism मतलब चोरी करवाना था है. બીજાનું કોન્ટેન્ટ ચોરી કરીએ એને સાઇટેશન ના આપીએ એ બહુ ગુનો કહેવાય અને એમાં બહુ સજા થાય, જાપ પણ જાય. જાપ કરતા હોય તો પેપર તો જાય, પેપર તો પબ્લિકેશન નથી થવાનું, યા થઈ તો વિથડ્રો થશે, જાપ હોય તો જાપ જાય. So that is why you have to be very, very careful. You cite the publications from where you have taken the data. So friends, this is about the last tip we have, and I think after that, thanks one. The last tip we have, here I want to mention, I told you in the beginning, plagiarism means similarity index. Text should not be similar. If it is similar, then it has to be revised. Nothing should be copied from others, word to word. If you do it, it is plagiarism. For that purpose, you have to rewrite it and cite it. And taking experimental data results from any other person other than you or from your own published work, if you do not cite, it becomes offensive. It becomes criminal. There will be severe punishment for that. Even we may lose our job. That is severe plagiarism. Otherwise, it is just similarity of text. Text can be revised so that same words, same sentences are not used, but meaning comes the same. So we have no right to copy, to take what I used to lift some data, some figure from others' work and claim it as hours work. It is as simple as you have stolen a car and bring it to your home and claim that this is my car. When the owner complains, police come and prove that this car belongs to somebody else. Imagine what will happen. Police will file a case of theft, and huge punishment is given. Here also in research, when we take somebody's data, somebody's results, somebody text, cannot. You must cite it, you must quote it. If it is text, you must revise it. So this is what is called properly attribute published content. And you know that copyright, there's one more lectures on copyright. When the journals publish these articles, it is copyright material. Copyrighted to whom? To the publisher. Without asking them, without seeking their permission, not even a single sentence can be lifted from that published content because they have copyright. You might have heard copyright violation. Copyright violation is a criminal offense. This is what American Chemical Society gave guidelines. This my last part of the work is basically based on those guidelines. I put them in a color form, in a different form, but actually the guidelines are in toto stated by them and they are in public use. I'm not claiming that this is my work, but this is what they say, and that is why we are propagating what they say as a scientific worker. So this is what I want to share with you, friends. I apologize for whatever the technical inconvenience which is beyond our control. Otherwise, normally I do a lot of things. I use Google Meet. We never have this problem. As far as internet is, it is working. My voice is going, but I don't know technical.